So today we'll solve a question from the IIT-JEE Advanced section. Yes, a very warm welcome to everyone. So today we'll solve a question from the IIT-JEE Advanced section. So let us see the question. The question is, correct options for the following sequence of reactions are. So we start with the toluene. The first reaction is bromination in the presence of light. So halogenation in the presence of light. We know what it is. This is our benzylic substitution. So we start with the toluene. And the first reagent is bromination in the presence of light. We know it is for the benzylic substitution or the allylic substitution. What do I get as CH2Br? Yes. In the next step, it is our Q. In the first set of reagent is Q. Second is reduction, hydrogenation in the presence of palladium and charge. So Q is KNO2 if we go with the A option, and if we see the C option, it is AgNO2. So look here, we know that this is our carbylamine reaction, and we know carbylamine reaction is a characteristic reaction of primary amines, right? So obviously we need an amine over here so that the foul-smelling isocyanide is formed. So if we want an amine over here, and this is reduction, so we know that we get primary amines via the reduction of nitro compounds. So we need a nitro compound after the reaction of P with Q. So this is our P. So Q needs to be KNO2 because we know that in the substitution reaction, if we see KNO2, we get nitro compound as the product, and if we see AgNO2, we get alkyl nitrite as the product, right? We get nitrile alkyl nitrite as the product. So what do we get? Yes, a very warm welcome to everyone. So today we'll discuss a problem from the IIT-JEE Advanced section. So let us see the problem. The problem is that we start from the toluene, and the first reagent is halogenation or bromination in the presence of light. We know that it is for the allylic or benzylic substitution. We get P. P upon reaction with Q followed by the reduction gives you R, and R on treatment with chloroform in the presence of a strong base gives a foul-smelling substance S. Okay, so we start with toluene. And the first reaction is bromination in the presence of light. So this is for the benzylic substitution, and what do we get is benzyl bromide. Now, after that, on treatment with Q followed by this hydrogenation or reduction, we get R. So this is our P. Now look here, we know that this is our carbylamine reaction. It is a characteristic reaction of primary amines to give a foul-smelling substance, which is your isocyanide, right? So for that, we need a primary amine to be formed, and primary amine is formed when P is treated with Q followed by the reduction. We know that reduction of nitro compounds gives us the primary amine. So we need something which gives us the nitro compound. So Q, if we see from A and C option, A is KNO2. We know that KNO2, when we treat we treat RX or alkyl halide with KNO2, what we get is your alkyl nitrite, ONO, as the ONO substitutes the halide. Whereas in this AgNO2, what happens, because O is already forming the bond with Ag, so we are left with the nitrogen end as the nucleophilic end. So we get nitro compound in the case of AgNO2. So this Q needs to be AgNO2. If it is AgNO2, we get a nitro compound, right? And after the reduction, we get the amine. After the reduction, we get the primary amine. We get the primary amine. So this is CH2, NH2. Is that okay? We get the primary amine. And after that, this is, like I said, it is your carbyl amine reaction. So what do we get is isocyanide as a product. So this is CH2, isocyanide as the product. I hope this is clear to you. Now, so and also P on treatment with V gives you S. So P upon treatment with V. So if you see here, it is AgCN and it is your KCN. So obviously what we require, what can be V? Yes, what can be V? So V is, if we treat it with KCN, we know what do we get? We get the cyanide compound. And if we treat it with AgCN, we get the isocyanide compound. So it needs to be AgCN. So by that logic, A is eliminated, also B is eliminated, right? So what I'm saying is that this is your R and this is your S. And from P to S, if you treat it with AgCN, you end up getting this. Why? Because this is a substitution reaction. Now there are another set of reactions. Toluene upon treatment with KMNO4, KOH heat followed by hydrolysis. I have told you multiple times that when we treat it with KMNO4, KOH followed by hydrolysis, what do we end up getting is the CS3 gets converted into COH. In fact, no matter how long this chain is, the primary condition is that there has to be an alpha hydrogen. This hydrogen should be present. As long as it is present, no matter how long this hydrocarbon chain is, it gets converted to the or oxidized to the acidic part. So what do we get is your benzoic acid. This is our benzoic acid. Yes, this is our benzoic acid. Now, so benzoic acid, so this is your T upon ammonolysis. We have ammonolysis. So ammonolysis of this followed by heat. What do we get? We get benzamide. We get benzamide. Now, what else? So this is your benzamide, and benzamide upon treatment with W gives you R. All right. Treatment with W. Treatment with W. Now, what can be W? What can be W? Yes? What can be W? So, look here. If we see the C option, C option says that R is phenylmethanamine. R is phenylmethanamine. Yes, C is absolutely correct. That if we have used Q as AgNO2 and R is your phenylmethanamine, which is absolutely fine. So C is definitely one of the answers. Now, W it is saying the LiAlH4, and yes, we know. In fact, when we discuss the methods of preparation of primary amines, we say that primary amines can be obtained by the reduction of nitro compounds, reduction of cyanides, reduction of amides, and also reduction of oximes, reduction of aldehydes or ketones when it reacts with ammonia. Yes, we get reaction with ammonia, we get imine upon reduction with, for say, we have the cyanoborohydride reagent, we get the amine, 1 degree amine. So yes, W is LiAlH4. This is a strong reducing agent, and we know that it converts amide into amine. Amides into amine. Which amine? 1 degree amine. Please remember 1 degree amine. Reduction of nitro, cyanides and amides gives 1 degree amine. Is that okay? So A and D both are correct. C and D both are correct. So the correct options for the following sequence of reactions are C and D. I hope the question is clear to you. So we will come up with more questions like this. So stay tuned for the next session. Thank you so much. Thank you.